Okay, some HL calculation questions. So HL has to deal with this equation, E equals H times frequency, H being Planck's constant. So if you're given the amount of energy in joules to break a bond, that's your E value. Solving for frequency is E over Planck's constant equals frequency. Once you have frequency, speed of light divided by frequency equals wavelength. So we can do that in two steps. So 8.23 times 10 to the minus 19 joules. Planck's constant is 6.63 times 10 to the negative 34 joules times seconds. And that will put us in per seconds for our unit. You should be able to see that the value should end up somewhere around 10 to the 15. And when we do this out, we get 1.24 times 10 to the 15 per seconds. Then we take that value, that's our frequency. We're going to do 3 times 10 to the 8th meters per second divided by that frequency. And we should ballpark that our answer will be around 10 to the minus 7 based on the exponents. And when I do that, I get the wavelength of 2.42 times 10 to the minus 7 meters. If I go look in the table in the data booklet that shows the wavelength of light, which is here, I can see that 10 to the minus 7 is about here, and that looks like it's right in the middle of the ultraviolet spectrum. So if they don't really ask this on the IB exams, but you could just say it's part of the UV part of the spectrum. Looks like it anyways. Now if we go forward here, a few more HL style calculation questions. Okay, once again, we have an energy amount in joules is released when every atom of hydrogen gains an electron, so that's the electron affinity. Now we want to turn that into a frequency, so once again E over H is frequency, and then down here it's finding the wavelength. Now you can do this question in the opposite direction. They could start you with a wavelength, you'd have to find the frequency, and then from frequency you could find energy, but we're doing it this way. So we do 1.21 times 10 to the minus 19 over Planck's constant. Again, judging your answer should be around 10 to the 15. When we do this one out, we get 1.83 times 10 to the 14, close enough. Makes sense since the bottom number is larger than the top, that will shrink the exponent by one place. And now I plug that in on the bottom here of our equation, 3 times 10 to the 8th divided by that frequency, and we get a 1.64 times 10 to the minus 6 meters. Now this last question is one where they've actually left the value as it would appear in the data booklet, with the ionization energy of hydrogen is 1,312 kilojoules per mole. So these values are always measured per mole of particles because the values per single atom are so tiny. Now, that means that you need to be prepared to turn values that are per mole into values per atom. That means we need to use Avogadro's number, and we want the value in joules instead of kilojoules. So one thing that we need to do is take 1312 kilojoules and make sure that we know that's this many joules, 1,312,000. So it's times 1,000 to get to joules. Now that's the joules per mole. And then we need to think about, well, how many atoms are there per mole? So we need to divide this by Avogadro's number, because Avogadro's number is the number of atoms per mole. And so I have this value is the energy per mole. Now I'll divide it by the number of atoms in a mole, and that will cancel out my mole unit. And I'll end up with the joules per atom, which is what I want, which will be a lot smaller. And so when I do that division, I get 2.18 times 10 to the minus 18 joules. Okay, so I think it makes sense that the energy per mole, if you divide it by Avogadro's number, which is the number of things in a mole, you get the energy per that thing, which is usually a particle. So in this case, an atom. Now, once you've got that, you're just doing additional calculations like we've been doing, which is energy divided by Planck's constant to get the frequency. In this case, that would be 3.29 times 10 to the 15th. and then wavelength, which is c over frequency to get wavelength, and we should get 9.13 times 10 to the 18th meters. So the only addition of that last question here is this idea of the per mole. You've got to convert kilojoules to joules, and then moles into atoms. So a nice link with Unit 1, be prepared to use Avogadro's number.